Hello and welcome, my dear students. This is Ehsan Ashfaq, and I welcome you all to another important lecture. And today, the topic of our lecture is Introduction to Requirement Engineering. So, basically, we will see that what is requirement engineering, what is its importance, what are the basic and important concepts which should be clear. So, remember that in order to understand the requirement engineering, we need to have a clear understanding of three concepts. First of all, what is a requirement? Second is what are stakeholders and what are their roles in getting these requirements? And the third one is what is requirement engineering. So let's start. First of all, let's have a look at what are requirements. Well, requirements are the expectations of the stakeholders or customer. Whenever you do something, whenever you buy something, whenever you do something new, you have some expectations from that thing, and you want them to fulfill, to get fulfilled from that your product or whatever you have purchased or whatever you have done. These requirements specify how the software should behave. By behavior, we mean the inputs and the outputs of the system and the relationship that the system establishes between the input and the output. These requirements describe the properties and features of the required software system. All the characteristics of the systems are defined by these requirements. They actually define and they actually introduce the basic characteristic that must be present in the system in order to be successful. Provide both guidelines and constraints for software development. But definitely, like all the development, all the software development, all the system development will be done according to the guidelines and the constraints provided by these requirements. There are different types of constraints which are applied on a project. They may be captured in a requirement, or they may be provided by any party or any stakeholder. These constraints normally include the scope constraint, the cost constraint, and the time constraint. These three are the very strict constraints that are applied on every project. Apart from them, there are different domain level constraints or the dependent constraints that are captured in the requirements as well. So overall, what are requirements? They define the characteristics and the properties and the expectations that a customer or a user has from a new system that is being developed or that is proposed to be developed in order to solve the problems that are currently being faced without that system. Secondly, what are stakeholders? Stakeholders are people or organizations who have direct or indirect influence in a software project. Whenever we are doing a software project, there are different types of people which are either directly or indirectly involved with the project. For example, the customer or the software development teams and the project manager and all the people directly involved or working in the organizations are the direct stakeholders. They are directly involved in the project, and some of them are indirect stakeholders. For example, let's take an example of an educational institute. The students which are studying in the educational institute, the teachers which are teaching over there, the parents whose children are studying over here, they are actually the direct stakeholders, while those who are providing the infrastructure, or for example who are providing the electricity, or those who are providing the insurance policies, and those who are providing the support infrastructure, they are indirectly stakeholders. They do not have anything to do directly with the study and the academics that are going in an educational institute, but they are indirect stakeholders. They are indirectly getting some sort of, they have some sort of interest in the project. So any person which have direct or any indirect interest, maybe a minor interest in the project, is this stakeholder of the project. And remember that these stakeholders have a huge, and are, I'll say, have a core role in getting the requirements, because these requirements are actually captured from these stakeholders, and these stakeholders are at the later stage are going to decide whether the project is a success or a failure. If the expectations which are actually captured in the form of requirements are fulfilled by the stakeholders, they are going to pass it, they are going to accept the new system. Otherwise, they will have to they will be definitely compelled to reject it, or to make it, or to call it a failure. Remember this thing, that this is very very important, that before getting the requirements we actually have to identify all the relevant stakeholders, because unless and until all the relevant stakeholders are not identified, we cannot say that we have a complete set of requirements. All the complete requirements can only be captured if all the relevant stakeholders are properly and in time identified, because as I said earlier, that later on these stakeholders are going to decide whether the project is a success or a failure. Now, after defining the requirements and the stakeholders, let's come to the definition of requirement engineering. It is a process of gathering and defining what the services should be provided by the system. These expectations will be captured in the form of the requirements, and then these requirements will be fulfilled in the form of the services provided by the system. Any service provided by a system to its user or the customer will actually be a result of some requirement that is gathered and captured at the start at the requirement engineering phase. The requirement engineering focuses on assessing if the system is useful to the business, means it performs the feasibility study. It involves elicitation and analysis. It involves the specification, and it involves checking that the requirement defined in the system is actually what the customer wants. That is actually called the validation. Because remember that there are two different things. There is a broad statement of interest that actually defines that what problem we need to solve. What is the broad statement of problem that is to be solved by the proposed system? And later on in validation, we check that the small and minor requirements given by the different stakeholders are actually contributing to the overall statement of interest. So that is the process is called validation. So I hope now it's clear that what are requirements, what are stakeholders, and what are their role in gathering the requirements, and consequently what is a requirement engineering. What is the goal of requirement engineering? As this stage, the requirement gathering stage, is actually declared as a complete engineering discipline. So there must be a very clear objective and goal behind it. So what the goal is that we need to capture to capture stakeholder requirements in a way that will minimize the risk of delivering a system that does not meet the desired and needs. If we deliver a system that does not fulfill the expectation and the requirements of the stakeholders, so as mentioned earlier, that these stakeholders are going to declare it as a failure at some stage. So the basic need or the basic goal of the requirement engineering is keeping in mind that it is one of the most important stage of software development life cycle, and later on all the activities performed at the later stages, including the implementation and testing and everything, depends upon the requirement engineering phase. So as I said, the level of completeness of the requirement at this phase will actually decide the success or failure of the overall system. So basic goal of this requirement engineering is that we want that we actually capture the complete requirements by identifying the key stakeholders, and later on we fulfill all these requirements so that the system is declared as a success. So overall, the requirement engineering is actually contributing toward the success of toward the increasing the rate of success of software projects. In order to understand the importance of requirement engineering and the problem that actually lies behind, which actually causes it to be a complete engineering discipline, can be understood by this diagram. Look at this diagram. Look at this first portion. A customer wants something. Now, what a customer wants, it is explained by the customer in this way. That is written that how the customer explained. This is what is explained by the customer. Now, how the project manager or a leader gets it, it's something like that. Now, this actually shows the understanding of the project leader or the project manager. Now, how he is now going to communicate it to the designers. How the engineers designed it, it is like this way. Now, this design is, or these algorithms are going to be given to the programmer so that the implementation in the form of code is done. So how that programmers actually implemented it in the form of code. After this, how the sales executive described it. Definitely they will describe it in a very beautiful way. So that is how actually this thing developed by the programmer is described in this way by the sales executive. How the project was documented, as you can see, a lot of efficiency over there. What operations installed, what the actual operation installed were this. How the customer was billed, the total cost of the project was like this, like if they have developed such a roller coaster, so it cost a lot. How the help desk supported it? It's almost, you can see the situation. But after all this situation, now what the customer really needed, it was something like this. Now, what the customer needed was this at the last diagram, and what the customer explained was this. And what the project leader understood was this thing. Now, where the problem lies? Now, we identify two key problems over here. The first one, that the customer is not able to explain what he requires. And the second one, that the project manager is not able to understand what the customer actually requires. So the problem lies at both the end. The requirement engineering will try to solve this problem by introducing such techniques and such approaches which allows a customer to explain the required thing in a better way, and which and also allows the project manager to understand the required thing in a better way. So we need to be working on both the ways, and we need to increase the level and the efficiency of communication between these two parties. So that is one of the goal of requirement engineering. And yes, another very important point which is managed and dealt by the requirement engineering is to deal with the conflict and changes. The one of the major cause of failure of the software project is the changes that occur at the later part of the project, and the customer demands some changes in the features or the characteristics of the project. So this requirement management, which includes the managing the changes to the requirement and the conflict that arises between the requirements captured by different stakeholders, is also managed by the requirement engineering processes. Where it fits, where the requirement engineering fits, as you can see, this is a diagram of system development life cycle, or a software system development life cycle. It starts from the requirement gathering, then the requirement analysis, that the system is designed in the architecture phase. It is written, it is architecture is decided, and the design is finalized, the coding is done, and the system then undergoes the testing, and later on it is implemented, and then the maintenance is done. Now you can see that the requirement engineering fits at the very start of the software development life cycle. It is that important, as I mentioned earlier, that the reason for declaring it as a complete separate engineering discipline is that the rest of the phases actually depend upon this initial requirement engineering phase, and the activities and the processes and the level of efficiency of the processes performed at the requirement engineering phase will later on decide about the success or failure of the overall software project. Example scenario, I think I have given enough examples in the previous slides, so let's move forward. Okay, requirement engineering activities. What are the activities that will be performed? There are basically 6 activities which will be stepwise performed. First of all, elicitation will be done. By elicitation, we mean that, as I described earlier, that first of all we will identify the key stakeholders, and we will elicit or gather the requirements from these stakeholders. The second thing is that the gathered requirement will be analyzed, and we need to identify the conflicts and the overlaps and the ambiguities that exist in the analysis phase. After the this is done, the next stage is the validation stage. That's where we check that whether the requirements given by the customer are actually contributing to the overall statement of interest or the statement of problem that is given and that is supposed to be solved by the new system. So we check the validity of the requirements. A requirement may be all right, but it may not be valid in a way that it is not contributing to the overall statement of goal or the statement of problem that is supposed to be solved. Next, after the requirements are validated and analysis is done, negotiation is done with the stakeholders in order to identify and in order to resolve the issues raised at the previous both stages. After that, documentation is done, and system requirement specification (SRS) document is prepared. And the last thing that is performed in the requirement engineering, as I mentioned in the previous slide, that the requirement changes occur, they should be managed carefully. So the requirement change management is also an activity of requirement engineering. So that is the relationship between these activities. You can clearly see that the documentation and the management is an ongoing process, and it is continuously performed with elicitation, analysis, negotiation, and validation. As far as requirements are concerned, so basically there are two different categories of requirement. In the first category, the requirements are categorized as user level and system level, and in the second category, the requirements are characterized as the functional and non-functional requirements. And now user requirements versus system requirements. So let's have a look at them, and let's clear the concept and the differentiate between them. User needs a high-level statement of the requirement, while system developer need a more detailed specification. That is obvious because the system developers are going to actually implement and solve this problem in the form of algorithms and the design and the architecture of the system. So they need a very clear and detailed description of the problem and the requirements. End user will not be concerned with the detail. They need a generic abstracted written requirement. They do not have to go into the detail. They just have to say what they need, what they require, and its rest is the responsibility of the developer that how these requirements will be fulfilled. While the people who are involved in the development, they need what exactly the system should do. So they need a more detailed requirement. What will happen when we do not have a clear differentiation or a clear separation between the different level details? You'll probably will end up with a lot of problems and misunderstanding if you didn't have a clear separation between different level details. So user level requirements, it describes the services that the system should provide and the constraint under which it must operate. And the main thing is that it is a less detailed one. It describes that how the system will be used and development constraints such as programming languages. What the system level requirement does, this level of detail is needed by those who are involved in the system development, as mentioned earlier, like developers and testers and analysts and designers, etc. And these system level requirements are more detailed. Let's have a look at the example of in order to clearly differentiate them. Look at an example of user level requirement. The proposed system shall generate monthly management reports showing the cost of drugs prescribed by each clinic during that month. So it is a generic requirement. It is written at a high level. Well, if we go into the detail of this requirement, let's have a look at the same requirement at the system level. On the last working day of each month, a summary of the drugs prescribed, their cost, and the prescribing clinics shall be generated. The system shall automatically generate the report for printing after 17 to 30 on the last working day of the month. Now, this is exactly the same requirement as quoted above, but it is at more level of detail. It is a more refined requirement. That is actually a system level. It is written at system level. So that is why it is more detailed. So I hope it is clear. The differentiation between the user and the system level requirement will now be cleared. What are functional and non-functional requirements? Well, functional requirements are those which define the functionalities or the characteristics that are expected from the system or that are required in the proposed system. It covers the main function that should be provided by the system. Functional system requirement describe the system functions, its input processing, its output, and how it is going to react to a particular input and what are the expected output, as I mentioned earlier. So all these are the characteristics of the system that are required in the proposed system. What are non-functional requirements? Well, and the other name of the non-functional requirements are the quality attributes. These are the qualities of the system that are expected in the proposed system. These are the constraints on the function provided by the system. For example, we may say that our system should have a high performance. Our system should be secure. Our system should be reliable. So this performance, security, and reliability, these are actually the non-functional requirements of the software system. The constraints like how many processes the system can handle, which is called the performance, what are the issues the system needs to take care of, which is referred to as the security, the rate of failure, this is called as the reliability, and the languages and tools, that is called the development constraint, and what are the rules you need to follow to ensure the system operates within the law of the organization, which is called the legislative requirement. Remember that in order to measure these non-functional attribute requirements or the quality attributes of the system, we need to have some software metrics. Software metrics are used to measure the quality attributes of the system. For example, in order to measure the reliability, we need to find out that how many times a system gets failed in a particular time interval, or for this may be a metrics for measuring the reliability, or in order to measure the performance, the metric, the software metric may be the number of transactions performed per second. So this may be used as the standard for the measuring the performance of a software system. Well, these are different non-functional attributes. You can go through them. They are divided into subcategories. And let me tell you one more thing. McCall, which is a scientist, he has written a complete research article on the non-functional requirements that may be required in a system. If you want to understand, or if you want to have a detailed look of the non-functional quality attributes, you should refer to the McCall's quality factor models, or McCall quality attributes for the software system. So it will help you a lot. Well, so this is now the requirement. This is very important diagram. You need to understand it, and in the coming lectures we are going to explain this diagram one by one. The requirement engineering process is in turn divided into 4 steps. The first one is the requirement elicitation stage. The second one is the requirement analysis and negotiation stage. The third one is the requirement specification stage, and the fourth one is the requirement validation stage. So these 4 stages actually combine to form the complete requirement engineering process. In the next 4 lectures, we will be covering these 4 different stages of the requirement engineering. Thank you very much. That's it for this lecture. If you have any question, you can write me down. I will try my best to answer them. And please do not forget to subscribe my YouTube channel for further lectures in CS and IT. Thank you very much.